Hi, my name is Reid Durtschi, and this is my video game audio demo reel for the 3D game Angry Bots. In this video demo, I will showcase examples of sound design, scripting, and adaptive music that I created and implemented into the game using the Unity 5 game engine. This includes creating new dynamic audio through the use of scripting, replacement of all in-game sound such as weapons and environment sound effects, player and enemy sound effects, and dynamic music compositions. The first thing I did for this project was decide which sounds I wanted to create and implement into the game. To do this, I had to find all the sounds used in the game and determine how they were attached to the game objects and events and scripts themselves. After tallying the events observed in the game, I created an extensive asset list of proposed sound effects and music that I wanted to create and implement into the game. In all, around 60 total sound effects and variations were implemented into the game. The machine gun was made up of 3 layers of sounds that included a mech layer, a punch layer, and a body layer. Each sound layer was looped, and all 3 played together simultaneously when triggered in the game. However, each loop varied in length. Having varying lengths of audio layers helped to create a dynamic firing sound each time the gun was fired, and kept the gun sound more interesting. To add realism to the game, I added the sounds of bullet casings being expelled to the ground. Specifically, I scripted the sound of the casings to trigger once the player stopped firing their automatic weapon. In order to implement this sound effect, I had to add additional code into the game scripts. I created a casings array in the auto-fired JavaScript file and populated it with several different sample variations of drop casing sounds in the game inspector. I wanted the bullet casing sounds to trigger immediately after the player's weapon stopped firing. I also added a short wait time of about 0.05 seconds before attempting to access the array to make sure all machine gun audio stopped. I made sure to set the conditions such that none of the machine gun layers were playing before telling the script to access the values of the array. If the conditions were met and no gun audio layers were playing, the casings array was accessed and the sound from the array was randomly played once using the play one shot method. Sound effects for the mech enemy included mechanical footsteps and processed and looped samples of washers spinning in a metal cylinder to mimic the effect of a running motor. Additional sound effects created for the mech included missile weapons and an alarm that went off when the player was sighted. In addition to sounds of the mech, I edited the mech enemy script to vary the pitch and volume of the running motor based on the speed and motion of the mech enemy. By scripting the pitch and volume to vary based on live game input, it offered real-time control over the enemy sound in the game, and really helped to enhance the realism and mechanical movement of the mech. Sound effects for the buzzers were created using humming sounds that were heavily processed and combined with 2 other electronic circuit and buzzing sounds. I then cut these samples into finite lengths that when combined could be looped to give the effect of continuous movement. This was important because I edited the buzzer enemy scripts that controlled variable velocity and pitch of the buzzer, and thus allowed for dynamic and realistic movement of the enemy drone during gameplay. It should be added that this sound effect was implemented into the game in mono rather than stereo, in order to give a greater sense of movement and spatial identity with respect to the player, especially when the buzzer was circling the player. The exhaust fans were created using personal samples from electric house fans combined with other samples from my sample library. Collectively, these samples were processed with a group EQ and then implemented into the game. The terminal doors in Angry Bots involved a lot of moving parts that worked in sync to create a fluid animation of mechanical movement. To coordinate this, I tested and edited a collection of samples that were arranged in a delicate sequence to reflect both the timing and probable sonic qualities of the terminal door movements. Through testing and revisions, I was able to come up with a sequence that I felt fit the game environment. Group EQ, saturation, and limiting was used to enhance the collection of samples overall. One additional piece of dynamic audio I created was scripting an original mechanism providing audio feedback related to low health. In the original game, there was no real way of knowing your health status unless you really paid close attention to the small health meter on the tank located on the player's back. As a way to provide additional game feedback to the player, I added code to the original health script. I included an audio clip of a heartbeat to play once the player's health reached a certain level. Using the low health clip variable to store a looped sample of a heartbeat sound, I set the clip to play once the player's health dipped to 30% or lower. At this point, the health script would trigger the heartbeat loop to play in the game until the player gained over 30% health or died in action. To enhance the game audio experience and bring additional feelings of excitement and engagement into Angry Bots, I implemented dynamic music that could change based on certain interactions between the player and the enemies and environments in the game. For example, I created multiple combat regions that triggered action-oriented music when the player was in the vicinity of a mech enemy. To create the combat zones, I created a transparent game object over the regions that the mech enemies traversed in the game. I then set the combat zone as a trigger to initialize the action soundtrack to play once the zone is breached by the player. Once triggered, an alteration in the music from the normal exploratory soundtrack to a higher intensity action-oriented soundtrack would commence. Additional stingers and hits were included when the player entered or exited these combat regions, and acted as a sort of cue for the players to notify the beginning and end of an action sequence. Overall, using the audio mixer snapshots of the various game audio parameters, such as exploratory and action music, stingers, and health-linked audio feedback, allowed for real-time volume control of the music and audio, and these parameters allowed for continuous and dynamic playback dependent upon the location of the player within the game. Thanks for watching my demo reel on video game audio and scripting.